Okay, so welcome back. Now, we're trying to figure out, again, a general rule to see what happens to any point that's on here. So what happens to both the x and y coordinates to a point as it goes through these transformations. So looking at our list of transformations here, so remembering that we had a reflection in the x-axis, a vertical stretch by a factor 2, and then left 1 and up 8. Which one of these actually affected the x-coordinate? Again, ignore the y for now. Which ones of these actually affected the x-coordinate? Well, again, going through this last point here that you guys just did, the reflection didn't change the x-coordinate, didn't move it left to right. The vertical stretch didn't move it left to right, only when we moved it left 1. So when we moved it left 1, we saw that our x values went down by 1. So any x value we had was subtracted by 1. And you can see that here with our x values here. When we started with an x value of 0, it wound up at negative 1. We started at 1, wound up at 0, started at 2, wound up at 1. Okay, so that would mean the other transformations all affected the y value. So let's think about what happened here. So let's start with our generic y value here. So when we had a reflection here, we went from a y value of 4 to a y value of negative 4. Well, what happened there meant that our y value changed sign. So that's what the reflection will do. It moves it from one side of the x-axis to the other, so the y value would move from positive to negative. Okay, then we did a vertical stretch by a factor of 2, and we saw that it also multiplied then the y value by 2, so it went from negative 4 to negative 8. So not only was it negative y, it's actually going to be negative 2y. So overall, we had a y value of 4. We multiplied by negative 2, we wound up at negative 8. Okay, and then the left 1 doesn't affect the y value, but the up 8 does. So when you move it up 8, the y value then goes up, well, 8. So we're going to add 8 to it. So in theory, this is a rule that now works for any point that's on this parabola, and if we use this rule, it'll tell us a new point that's going to be on the new one. So let's take a look at it. Let's try it. So let's take another point that's on here that we haven't tried yet. So if we look on here, when x equals 3, y equals 9. Okay, and instead of actually going through the transformations on the graph, let's use our new rule here. So let's take 3, 9 and throw it into this new rule. So if x is equal to 3, okay, the x value is starting with is 3, so you have 3 minus 1. Okay, the y value they're starting with is 9, so we're going to have negative 2 times 9 plus 8. And it's just a matter of figuring out basically simplifying it and seeing what our new point is going to be. So 3 minus 1 is 2. Okay, negative 2 times 9 is negative 18, plus 8 is negative 10. So this tells me that when I start with that, my point 3, 9 gets mapped to a point at 2, negative 10. So is 2, negative 10 somewhere on this new parabola? It is down here. Okay, so it does work. And we could do it again for any other points. We could try this point here, negative 1, 1, negative 2, 4, so on and so forth. And again, it'll all give us points that are on this new parabola. So what we came up with here, this right here is called a mapping rule. Okay, and again, what it is a general rule that will take any point that's on our original graph, original equation, so in this case y equals x squared, and once you throw those points through this mapping rule, it'll tell us where those points are being mapped to on our new quadratic. So it'll give us an opportunity to now be able to graph anything that we want. Okay, so also, just in terms of definition here, these are original points right here, so 0, 0, 1, 1, 2, 4, and 3, 9. The points that we get after all the transformations, after using the mapping rule, these right here are called image points. Okay, so the image points of the original points that we had from y equals x squared. Okay, so now coming up with a mapping rule, hopefully, if we look at the mapping rule and look at the equation it came from, we can start to see a little bit of a pattern as to where the different values came from. So if you see here, if in fact we look at our transformation, we see they're moving left 1, well that told us the x minus 1 part of our mapping rule. We had a reflection in the x-axis, a vertical stretch by a factor of 2, which gave us that a value of negative 2, which told me here that my y value is multiplied by negative 2 in the mapping rule. And this plus 8 in the equation was our shift up 8, which gave us the plus 8 inside the mapping rule. So if we can go straight from getting the equation to the mapping rule, again, we should be able to go through this whole process of making the graph much, much faster. Okay, so before we get too much further along with this, I just want you to practice here. Here's a couple different equations. For each one of these, I want you to actually determine what the mapping rule would be. Then I want you to list the transformations, whether it's been vertically stretched or compressed, whether we have a reflection in the x-axis or not, whether it's moved left, right, up, or down. So please list those as well. And then I want you to see what the image point would be of negative 2, 4. So if you look back at y equals x squared, negative 2, 4 is a point that's on y equals x squared. So using the mapping rules that you're going to come up with here, what would that point get mapped to on your new parabola? So I'll give you a minute to try those on your own, and push play and you're ready to go through them together. Okay, so look at our mapping rules here. So for the first one, we should get a mapping rule of x minus 5, and then 3y minus 7. Now, if you'd prefer to start with the transformations first, that helps you create the mapping rules. From the equation, we have an a value of 3. That tells us we have a vertical stretch by a factor of 3. This plus 5 means here we're going left 5, and the minus 7 means we're going down 7. So we go left 5, down 7. So if this helps you create the mapping rules, instead of getting it from the equation, feel free to do that as well. And again, to create the image point, what we're going to do is we're going to take the negative 2, 4, and put that in the mapping rule for x and y. So our mapping rule here of x minus 5, so that's going to become negative 2 minus 5. Okay, 3y minus 7 will be 3 times 4 minus 7. Okay, so I'm going to simplify that, and it tells me my new point, my image point, is going to be negative 7 and 5. So in theory, this will be a point that is on the equation y equals 3 bracket x plus 5 squared minus 7. Okay, so for the second one, our mapping rule will be x plus 1 and negative 2y plus 6. In terms of our transformations, a negative 2 does two things. It gives us a vertical stretch by a factor 2 and a reflection in the x-axis because of the negative. And here, for our mapping rule, you can see it's plus 1, so it moves right 1, and we go right 1 and then up 6. Okay, if we use that mapping rule, our image point from negative 2, 4 will be negative 1, negative 2. Okay, so in general, again, the whole idea here was be able to make graphs of quadratic functions. So to the steps that you want to do if you ever want to graph a transformation, first thing you're going to want to do is take key points from the original quadratic. Now, almost always our original quadratic will be y equals x squared. So think about some key points that are going to be on there. Okay, so 0, 0 is obviously 1. Okay, you can fill in a table of values and get a whole bunch of others. You can get 1, 1, 2, 4, 3, 9. You can go into the negatives and do negative 1, 1, negative 2, 4, and so on and so forth. You can go on forever, but you're just going to get a selection of key points from the original quadratic, which is going to be y equals x squared. Okay, and then you're going to have the equation of a new quadratic that you're trying to graph, right? So you're going to try and create a mapping rule that will go from the original quadratic to the transformed quadratic. Okay, so our original being y equals x squared, create the mapping rule that goes from there to our new equation, so just like we've been doing so far today. Okay, and then all the points that we came up with in y equals x squared, we're going to throw those into the mapping rule to obtain all the image points. So these image points, again, will be points that are on your new parabola. Okay, so we're going to plot those points, and just as a nice check to make sure that we're on the right track, check that our vertex, our direction of opening, and our shape of the quadratic seem reasonable. Okay, if you get anything that looks a little bit off, odds are you made a little math mistake somewhere. Okay, so these are your general steps anytime you want to graph a quadratic function, especially if you're going to be using transformations for it. So let's try and put that to practice. So let's run through these steps. The first thing I'm going to do, we have y equals negative 2 bracket x plus 3 all squared plus 8. Okay, now I've taken some points here that are on y equals x squared. So these are all points from y equals x squared. You got 0, 0, negative 1, 1, 1, 1, 2, 4, and so on and so forth. So looking at this guy right here, hopefully you can create a mapping rule. Okay, so our mapping rule is going to be x minus 3 and negative 2y plus 8. And now we're going to find the image point. So I'll do the first one for you. Again, negative 2, 4, we're going to throw those into the mapping rule for x and for y. Okay, so for negative 2, 4, okay, I'm going to wind up with negative 2 minus 3, and then negative 2 times 4 plus 8. Okay, so negative 2 minus 3 gives me negative 5. Okay, and negative 2 times 4 is negative 8, plus 8 gives me 0. So that's going to be a point, an image point is going to be on my new graph, and I can actually go ahead and plot that right now. So negative 5, 0 is right there. Okay, so what I'm going to have you do now is repeat this process for the other points that are in the table right here. So find the other image points, plot them, and check to make sure that your graph makes sense. Okay, so take a few minutes to do that, and then push play when you're ready to see the answer. Okay, so there should be the rest of your image points. Okay, so if you plot these, so we have negative 4, 6, negative 3, 8, 2, 6, and negative 1, 0. So it sort of looks like it's formed the shape of a parabola. With your pencil, you can create a nice smooth curve going through all those points. Okay, and there's our parabola. Now, again, just to make sure we're on the right track, see that everything seems reasonable. Our direction of opening was down. Does that make sense from our original equation? Well, yes, because the a value is negative. Okay, I have my vertex here at negative 3, 8. Does that make sense from the equation? Well, yes, because that came from my positive 3 in there and my 8 there. Okay, does it seem like a parabola? Yes, it does. So again, we're on the right track here. We've now created a parabola just by using a mapping rule and throwing points into that mapping rule to find image points. Okay, so that's our idea. That's the whole idea behind graphing these types of equations. There's some good homework there. They'll give you good practice, and then we're going to move forward, work more with this type of. It's a new form of a quadratic that really we're looking at today, and we're going to look more at it into the next lesson. So try the homework here first, and then we'll see you in lesson 30. Okay, cheers.